Hello everyone, I am here to introduce our team project, Shortest Path Application, to you. It is a convenient visualization tool for backpackers or common travelers to search the airport information around the world. It can also be used into different B2C platforms to help users to save time on buying tickets, especially in this pandemic period. We use Streamlit, Tigergraph, React, and a little graph history, as you see. So the first function is the data overview. You can have a look at the data by click here, and the graph history will show you a very fantastic type data like this. Let's zoom in. So if you want to see the details of the data or the age, you just click on the points or click on the age. The detailed information will show on the right corner, and you can also do some filters here. I won't go too much into details. And here's a table. You can compare the different data, different ages here. So let's quickly go to the shortest path. So in this section, we implement the shortest path using two kinds of graph. One is the unweighted graph, another is the weighted graph. So first we go into the unweighted graph. Here you need to input two stops. Let's say CNX. It's a Thailand airport. So if you only input one airport, you can see a blue circle here. If you click here, you can see the details of it. So a second stop is asked. So let's say we input the SJW. It's an airport in China. So you can see all the shortest paths here, and I will select one, and you can see the airport shortcuts, the stop airports, and the latitude and longitude in the data frame. Okay, and then we can see the path on the map. You can zoom in and zoom out to see the details. The green circle is the end, and the blue circle is the start. And if you click the right airport here, you can find it is the second airport. So let's go to the weighted shortest path. In this part, we implement a click event, which means first let's select a country. Let's say Canada. Okay, so you can see all the airports on the map, all the airports of Canada. Just random select start and select the terminal. You can see that's a click event, and here your selections are shown here, and we search a path. Oops, no path found. Let's try it one more time. Okay, hope this time it can work. Actually, you can zoom in to see the detailed information of each red point, but consider for the time limit, I just randomly click two of them. And to be honest, this part needs several seconds to run, which is something we can improve in the future work. Woohoo, no path found. But it can work. So we just move on. Okay, let's just move on to another function, the centrality. Some of you might not be very familiar with the centrality, what it is, and how it can work. But don't be worried, I will explain it to you sooner. So we first choose a country. Let's say Australia, okay? And the max cubes, you can change it, is a parameter of the algorithm, and it limits the search depth of the algorithm. So we just let it be 4, and we just wait. Okay, so it shows 4 maps. That is what the part of the centrality, degree centrality, closeness centrality, betweenness, and PageRank. Let me explain it one by one to you. So let's zoom in here. So the degree centrality we only compute the out degree centrality, which means the big circle means that most airplanes fly from this airport. That is the out degree centrality. So that means that this place is a good position to start a travel if you are a traveler, randomly traveler. And let's go to the closeness centrality. The radius of circle shows the closeness between itself and all other points, which means if you want to find some place close to others, you need to choose big circle in this picture. So this circle is very close to all other points. Okay, so let's go to the third picture, betweenness centrality. Considering the algorithm, the radius shows the frequency that points shows on all the paths. So in other words, if the circle is big, that means many paths go through that point. Like this point, we said this point start and it goes to here. It is most likely to go through this point. So intuitively, this centrality is similar to the first degree centrality because the score depends on how many paths go through it, and this radius depends on how many paths start from it. So it has some the algorithms have some overlap, and we can see the picture verify my institution, right? And let's see the finally PageRank. So the PageRank means that the radius in this picture shows the number of referrals to each point. So in other words, if the circle is big, that means many airplanes fly to here as the terminal. So that might be a recommended final stop for a traveler, but not the start position. And here, if you click on the checked box, we can narrow it down to a city region. Let's say Boston. Enter. So the city region, it's similar to the country region. So I won't go into too much details. There's something worth to be mentioned, that there's a histogram. It shows users can, it shows the 4 kind of data in one chart, and users can directly compare the relationships between the data in these 4 maps. Okay, so that is all about our project. Thanks for watching.